Hello, everyone. Good morning, good afternoon, good evening. Thank you so much for joining us here for our latest session of our CCNA Prep series. My name is Rigo Villa. I'm one of the community managers on the Cisco Learning Network, and I'll be your host today. Before we dive in, I wanted to take a brief moment to talk about the CCNA Prep program and also cover a couple of housekeeping items. If you're joining us for the first time today, the CCNA Prep program provides valuable insights through live sessions that are led by our subject matter experts. We'll get to explore the latest exam topics, offer opportunities to test your knowledge, and we'll also share some resources to help aid you in passing your CCNA exam. And speaking of those resources, we do have supplemental activity files for both CML and Packet Tracer, and you can download these at any time. You don't need them right now to enjoy today's session, but they will be very helpful for practicing on your own time. We will be sharing those resources, so we've got you covered there. Also, if you're tuning in but have not officially registered for the program, I do encourage you to do so by scanning the QR code on your screen. This will ensure that you are notified of our upcoming events, and you can also get access to the resources, and you can also be informed when these sessions become available on demand. Now, I just wanted to take a moment to address the Q&A and quiz questions for today's session. This will be an interactive session, and you can participate in our quiz questions, submit your questions, and access the resources via Slido. If you need to log in to Slido to engage with us, please go ahead and scan that QR code on your screen, or you can also do so on our CCNA live streams page. Last but not least, at the end of this event, we are going to be launching a Slido survey that would be greatly appreciated if you can just take a moment to submit your feedback and let us know how you like today's session. We always look forward to receiving your valuable feedback. And so without any further delay, I'd like to introduce today's stars for the session. We have our presenter, lead content advocate, Patrick Gargano, and he's also joined by principal engineer, Hank Preston, to cover our topic for today. And we're going to be diving into navigating NAT, bridging private networks to the internet. Hey guys, how are you?
Good yourself, Rigo. How are you?
I'm doing great, thank you. Looking forward to this session today.
Yeah, nice to see you all again. Hey, Hank.
Yeah, it's good. I got to admit a little bit. I gotten so into just listening to Rigo do the introduction that for a split second there, I forgot I was presenting. So when he went to introduce us, I was like, "Oh my god!"
Oh,
And then I was
it's
like,
not passenger
"I'm
mode.
out of control."
It's not passenger mode. It's co-pilot mode. Right.
Yeah, yeah. Ooh.
Well, hey everyone, welcome back. Yes, it's season 2, episode 3. We're focusing on NAT. If you remember, episode 1 was all about DHCP. Episode 2 that was live from Amsterdam was on DNS. And we're just kind of adding now another service in our network, NAT, network address translation. And we're going to look at a bunch of different flavors of NAT. Before we jump into this, maybe let's have a quick look at the Slido to see where people are from this time around.
Yeah, I'm always excited to see who's joining us and where they're
Nice.
off. And we do have a really nice kind of broad reflection, right? We got several folks from here in the U.S. We've got some fellow Canadians from you. I see
Yeah.
Quebec is kind of called out there.
Yeah, I know. I saw that.
Spots, which is great. Awesome.
Bonjour les Québécois. A little French for you there. No, yeah, no, a good turnout again. Listen, honestly, this is my first. It's the first part of our sessions that I really enjoyed, looking to see who's joining from where around the world, Africa, Middle East, Asia. I know the time zones are a little challenging for some of you. Maybe you're watching actually the recording, so thanks for doing that and joining us for that.
Yeah. The other part I really like about pointing that out, and I talk about this a bunch, I think we mentioned it when we were in Amsterdam, is that sometimes it can feel like when you're studying for something, particularly in kind of a space like computer networking, that you're all by yourself, right? You're the only person trying to figure this out. Well, just look at who else is here with us on this CCNA Prep webinar series, coming back bi-weekly, dealing with Patrick and my bad jokes, and also picking up a little bit of networking knowledge, right? There are folks all over the world in the same place you are. So be excited, be part of this community. And that's a big part of what I enjoy about the Cisco Learning Network and all of these areas that are here, is the chance to kind of reach out and chat with all of you guys that are there. So, and today we got one of my favorite topics, right? It doesn't compete, right? It's really not up there with DNS with me.
Not quite.
I think I made it pretty clear DNS might be my favorite topic that's out there, but NAT NAT's a pretty important one, because there's a joke that comes up a lot. I've made it myself a few times. It's like, how do we solve problems in the networking space, right? We solve so many problems the same way. It's always just NAT. It's translation, right? You don't like this address? Great. We'll give you a different address. You're not ready for IPv6? That's fine. We can solve it with NAT. And now we're going to see how we solved IPv4 address exhaustion and not having to deal with some of those problems, 2 decades ago. And NAT continues to solve this problem for us. So how are we going to dive into this, Patrick?
And that's exactly where I wanted to start back in the 90s. And I was thinking, should I hum some sort of a 90s hip hop song? And I got requests, and I said, no, I think the one attempt at humming the intro to Game of Thrones was such a success. Anyways, so back in the 90s, and you might have read about this as well, folks that are watching and chat, you would have come across the great fear, right, of the 90s, which is we're going to run out of IPv4 addresses. It was like the sky is falling. And to be honest, they were right. We were handing out IPv4 addresses to different regions in the world, who were then handing them out to service providers in those regions, who were handing them out to customers, and everyone was just gobbling up these public, right, these internet-facing IPv4, mostly IPv4 addresses at this point. And so groups got together, different organizations, different companies, to try to come up with some solutions. And I've kind of listed them on the right here on the CML topology diagram. Let me zoom in a little bit so you can see them a little bit better. Obviously, we want to talk about NAT, which is, as Hank was saying, the translation, the functionality that allows a router or firewall to translate an address to another one. Typically, in our case, it'll be a private address to some sort of a public-facing internet accessed IP address. But there's a bunch of other things that go with that, right? The private networks themselves. And again, I created another little table there just to remind you what those private networks are. So as you're studying subnetting and IPv4 and VLSM, I'm sure you're encountering this concept of private addresses. But it wasn't just that. They came up with a way where service providers could aggregate routes, right, Hank? It was like, and I don't know if I don't think I invented this. I actually looked in the RFC, and the word supernetting is actually mentioned there. We talk about subnetting, but I don't know, what's your take on supernetting or aggregation?
Yeah, I mean, it's an important piece that goes through there. I think that's one of the interesting elements, right? When the internet and TCP/IP came out, it was still a very small selection of the world that was involved. It was research organizations, it was universities. Yeah. And then as the excitement about the potential for the internet grew, and we saw as the internet started to grow faster and faster and faster, fairly quickly, it was this recognition that like the sizing was going to be a problem. And things like how much memory computers took. If we think back to when some of these problems were first out there 20, 30 years ago, right, memory was very expensive. So router memory was really expensive. And we needed to come up with ways to solve not just the IP address exhaustion problem, but the fact that all these addresses were all over the place and they needed to have ways to organize things and say, okay, we're going to kind of send stuff in different directions. We often talk about the kind of the post office mechanism and analogies for like delivering network traffic that's in there, right? If the only thing you wrote on an address was like, I want to send something to Patrick Gargano in Canada, right? How do you ever get that to Patrick, right? Do you just walk it like one post person just walks around Canada looking to give it to him? No, we've got zip codes and countries and states and then streets and eventually down to the address. And that's where things like the supernetting and the summarization comes in as a way to kind of break things down so that as packets travel through the internet, right, they can get to like broad areas and say, okay, we start off and we say, okay, well, this third of the internet is over here, so I'm going to go that way. And then we further kind of break it down until we very quickly in relative terms, because we're talking often less than a second at this point, right? We end up back kind of exactly where we're trying to get to. And it's these technologies is what allows it to happen.
And what I find interesting here is in CCNA, we focus a lot on subnetting, and everyone knows what that is by this point, hopefully, right? You've got a large block of addresses and you cut it up into some smaller chunks. The supernetting, like Hank is saying, is kind of the opposite, right? We've got all of these small chunks of networks that are deployed, but this service provider is going to aggregate or summarize that and then send that to the next service provider, for example. So impacting that routing table size. And then everyone's favorite, the other solution that they came up with in the mid-90s is starting to create IPv6, right? That standard to come up with a solution that, right, that would help the problem of IPv4 address exhaustion again. So.
Yeah.
So there you go. That was a little summary of the 90s.
No, it's a good one to go through. And IPv6 is another topic. We'll have to figure out when this falls into the CCNA prep webinar series kind of seasons to go through. But it's an exciting one. I remember when I first got into networking, like learning about the basics of it, but nobody was really using it outside of kind of specific pockets. This past year at Cisco Live in Amsterdam was kind of a banner year for IPv6. They deployed some new IPv6 technologies. We started to see IPv6 traffic actually slightly edging out IPv4. So this is going to be a topic, I think, over the next 5 years or so, that's the future network engineers, right? Future CCNPs and CCIEs. I'm talking to all of you on the CCNA prep series here, right? You're going to be out there doing more and more IPv6. So we'll see more of that as well, kind of in the future.
For sure. And it was nice to see it natively deployed, like you were saying, at Cisco Live as well on the wireless network. That was very, very impressive as well. So, okay, so that was the little tour of the 90s, and kind of just setting the scene for why we need to talk about this. And obviously, a lot of these things are covered in the CCNA. So we're doing NAT and private addressing today, but all of that route summarization, kind of part and parcel with the subnetting that you're learning about as well. And obviously, IPv6 is a big part of the CCNA. So let's move that over to the right for a second. I just want to kind of refocus our attention on, what the whole point of this series was, Hank, right? When Hank and I sat down, we were like, okay, let's create a series which really focuses on the configuration tasks. And if you've looked at the blueprint and you've looked at NAT specifically, you've realized that there are actually quite a lot of configuration tasks relating to NAT. You've got dynamic NAT, static NAT, and then what we call sometimes NAT overload or port address translation, PAT. Now, in this short session that we've got, we're not going to go into all the theoretical details of how all of these works. We'll hit on a few things, but really what I want to do with Hank is obviously just demo what that looks like, from a configuration perspective and see what the differences are. And just before I jump in, although it lists 3 different configuration tasks here, we're actually going to do 4. We're going to do dynamic NAT, so that will be NAT with a pool. And then we're gonna do 2 flavors of overload or of port address translation. We'll start by overloading the pool, so that pool that we'll have configured, we'll overload that, and then we'll overload the interface, right? So we're going to look at those 2 different ways of using the overload keyword, and then we'll wrap up with some static NAT as well. So that's awesome. That's the run of the show, really.
No, I like it. So sometimes, right? So we've got our Slido questions that are going through, asking people kind of gauge their NAT knowledge that's in there. Do you think do we want to check and see how people's knowledge on our first question are before we go in and kind of dive into that aspect? So let's bring Rigo back, and take a look at our first kind of technical question that we've thrown out there. So what do we got, Rigo?
Yeah, thanks, guys. So in our current poll, the question was, which type of address is the private IP address of a device that initiates a NAT translation? And just by looking at the results, there is one standout choice, and that is inside local.
Nice.
That has an overwhelming majority of over 85%. Yeah, what do you guys think of this answer?
Looks like folks know what they're talking about here, Hank. So this is going to be a solid session. We'll obviously use that show IP NAT translation command as we go through the lab. But yes, the inside local address. And I just want to remind folks, and before I hand it over to you, Hank, as well, I just want to remind everyone, right, the guide, this whole lab that we're going to walk through is all broken down in the guide in CML. We've extracted it as a PDF as well. You'll be able to download that. We've got the packet tracer file. But I did have time within the guide to add a bit more information, theoretical concepts of what these are here. If you look at that list, Hank, how do you, your little sentence for each one in terms of, if you had to explain it to your son, for example, right, he's going through CCST, he's going to want to know and understand NAT. What would you tell him?
Oh, no, he's definitely going to go through there. And so before I answer that one, I do want to comment that I'm super, super proud and giving credit to the folks on the stream for this. This is one of those hardest, like, multiple choice questions that we prep for the CCNA exam, because it's just a verb. It's like it's a vocabulary. How well do you know these terms? And they break in. But to your question, there's a way I've always broken it down. So each one of them, there's 2 words. There's inside or outside, and then there's local or global. And so for me, the first word is like, where is this host? Right? Where is the host? Is it inside my network? Or is it outside my network? So that's the first part, right? So is it inside the network or outside the network? Do I own it or does somebody else own it?
Nice.
And then the second one is just the address that we're talking about, is that relative to when I'm referring to this host inside or outside? So an inside local is a host, and it's the address that we refer to it when we're inside, we're local to our environment. And then inside global, it's still the host inside, but now it's how we refer to it in the outside world, in the global area that's there. And that, though, if you can keep those two things in mind, usually it helps you kind of focus in on however the question might be phrased.
I like it. And when we logged in earlier before the stream started, I shared my screen with Hank, and Hank was like, "Ooh, your topology got all nice and pretty. I got, added some colors, and I did put in very large letters at the top there. It's got inside network and the outside network. So I'll take a few seconds just to explain what the setup is before we jump in and start configuring. So on the right side is our inside network. It's our private network. We've got a DHCP client at the top right. It's sitting in the network 192.168.10.0. We've got an internal server. It's sitting in the network 192.168.30.0, and it has a .30 address itself. I'll come back to that other address in a second. We've got our edge router. That's where we're going to be doing all of our work, really, right? All the configuration for NAT is going to happen there. I created a loopback address there, just something to ping. And we're also going to use that as the DNS server address, because if you remember the DNS episode that we did a couple of weeks ago with Hank in Amsterdam, we saw that we can actually configure a Cisco router as a DNS server. I was just trying to keep the topology as simple as possible. So I've actually configured DNS on the edge router, and I'll show you that in a sec. Mm-hmm. We've got our link to the ISP router, and then it's connected to an external server. The one thing I just want to kind of point out before we jump in to start configuring stuff is that 209.165.200.0/29 subnet. So I want you to think about it this way. So the edge router, it's my router, my corporate router. I rang the ISP. I said, "Hey, Mr. ISP, I'd like a publicly routed block of addresses, and I'd like 8 of them," right? So a /29, that would be .0 to .7. So that's 8 addresses. The .0 is the subnet address. The .7 would be the broadcast. So that leaves us, let's say, 1 to 6. You can see that the .1's been configured on the router ISP interface, and the .6 has been configured on the edge interface. That means all we have left now is .2, 3, 4, and 5. What we're going to do in a few minutes, we're going to create a pool out of the 2, 3, 4 address. So it's going to be a very small pool of 3 addresses. And then the .5, we're going to come to it at the end. I've saved that one for our static NAT. So hopefully, Hank, does that make sense?
No, it makes total sense. And the other thing that I think is important to kind of hone in on here is this is the kind of skill that is very practical that network engineers have to do time and time again when you're setting up an environment for a small customer, a medium-sized customer that goes in. This type of concept, getting a /29 from an ISP, is fairly standard, right? Some of my earliest jobs as a network engineer was doing this type of work where I'm helping my customers set up their ISP. They're given a small block of addresses. We need to use it. So this is really practical for the kind of work a junior engineer, network engineer, may be asked to do kind of in your job. So really practical skill sets here. Patrick, you're going to walk us through.
And as I said, this is episode 3. We did DHCP, we did DNS, so I felt we needed to include that in this configuration as well. So that's why that PC1 is in a DHCP service network, and you can see the config there on the CLI output. You can see the DNS server is pointing to that loopback on the edge router. It's a really, really basic, really simple DHCP configuration, excluding the first 5 addresses. And then as I scroll down, you can see there's a little bit of DNS configuration. We're not going to kind of go over that. We did that a couple of weeks ago, but just trying to kind of point that out. And then from there, it's pretty straightforward. It's got a very simple routing table. I just want to point this out quickly. So the only thing I've got, we don't have OSPF running. The only thing I've got a default route configured on the edge to say, hey, if you have any traffic you don't know what to do with, don't drop it. Just send it to the ISP, and the ISP will know what to do with it. All right. So that's the only kind of routing I've got configured now on this particular device. So excellent. I think we're ready. I think we're good to go here. So
I think so. Let's get some internet access going.
Yeah, for sure. So let's do a couple of little tests. I just want to show you what kind of connectivity that we have right now. So first of all, I need a ping maybe. I should be able to ping, obviously, that loopback address that I mentioned a few seconds ago. So that was from PC1 that I just pinged to the loopback. I can also obviously ping the internal server. Just going to show you a little connectivity. That should work fine. That's fine. The only thing I want to prove now is that I've got no outside connectivity. So if I try to ping that 192.168.10. So the 209.165.201.10 address is that server on the far left. This should not work. I don't have NAT configured. I just want to point that out. I haven't kind of gone ahead of myself here and pre-configured things. So I've got no connectivity to the outside network. So here we go.
Yeah, before you jump into that, so a key piece here to remember, right? The idea here is inside we're using those private addresses, the 1918 addresses. So even if Patrick, if this was a real world environment, even if Patrick wanted to make his inside addresses be able to reach the internet-based world, the web server that's out there, it wouldn't work, right? You're not allowed to send a source address like 192.168.10 dot something outside. So we have to have NAT configured for this to function. So again, I don't want to keep harping it, but this is like a really practical example of what network engineers need to do to bring companies online. So,
and can I just add, Hank, right? It's not just that you're not allowed or it just won't work. The ISPs are filtering, right? They're filtering these. So if I try to send an internet bound packet with the source IP in the 10 or the 172.16s, right? So any of those private addresses, one of the most basic fundamental filters that ISPs have is to look at that and then just drop it, right? They know it shouldn't be sent out across the internet. So listen, Hank, I mean, I've got a specific order that I was going to go through this, but I'll just put you on the spot here. I mean, there is, to be honest, I don't think there's any real correct order when configuring that. There's a bunch of tasks, obviously. I'm curious to know, just out of what your steps would be. What would be the first step for this? Is dynamic NAT with the pool, basically, we're talking about.
Gotcha. All right. So the first thing I would usually do is sit down and figure out like which hosts do I want to allow access to the internet. Excellent. So how do we figure out which hosts or which networks? Because typically we wouldn't do this host by host. So which networks are we going to allow? And so we identify hosts with an access list. So Patrick's given us a nice ACL here. I like the real old school, right? Just ACL number 1, numbered access list, super simple, right? Just identifying what we're after. I was really curious what your wildcard mask there was going to be starting with a 90.
Exactly. So there we go. I've created a very simple access list. Like Hank, I didn't even name it. It's just a standard access list, number 1. And I just matched the 2 internal networks, right? The .10.0 network and the .30.0 network. So in other words, these would be the networks where hosts are that would be allowed to NAT. Cool.
Right. And so if you're going to, we're going to keep going. So now we know who we're going to allow out. Now we need to know NAT is a translation, right? So we're going to need to translate the inside addresses to those global addresses that are there. So the local address to a global address to stick with the terminology. And this is where the pool comes in. We need a list of available valid addresses. And so we're going to put some of these into a pool. All right, so with this pool configuration I'm watching here, it looks like you've identified 2 addresses. So does this mean my pool's made up of just the .2 and the .4 address, Patrick?
Oh, good. Oh, I see what you were trying to do there, Hank. No, in fact, it's a range, kind of like those DHCP excluded addresses, right? When we talk about DHCP, we would give it a first address and a last address. So that's a range, right? So in this case, I'm creating a quite small pool, but it's actually from .2 to .4. So .2 address, .3, and the .4.
Yeah. And a key area here, right, to hint in something you might be asked in an exam is that last address part of the pool, right? Is .4 a valid address? And in this case, yes, that is a valid address to be issued.
Yep. What would be your next step here? Would you do the interfaces or bind this together?
Yeah. So normally my next step, if I was actually just kind of firing this off, is I would probably go in and identify the address, the interfaces on the router, which ones are inside and which ones are outside.
So E00, Hank, inside or outside?
Well, I'm looking at your beautiful color diagram, and it looks like E00 on the edge router is outside.
Perfect.
And then E101 and 102 are going to be inside, which I think is an interesting aspect to go through here as well. We could have on a router like we have here, multiple inside interfaces, all heading out to the same outside address.
Yep.
Now, in a more advanced configuration, you can have multiple outside interfaces as well, but we'll keep it simple here where we've got lots of inside interfaces trying to get out to the internet through one interface. All right,
one last thing, this is actually turn this whole thing on, right? So
So we need to identify.
And I just want to point this out again. If you have a look at the CCNA topics, it talks about inside NAT, right? So and this catches out some folks because it is possible to do outside NAT as well. But for the CCNA, we're focusing on inside NAT. So IP NAT inside. So that's the kind of flavor of NAT that we're enabling. And now I need to tie two things together, that access list and that pool, right? So we're going to do source. What is the source? The source is, as you can see, I need the list, and it's the list number 1, right? That's the access list we created a few seconds ago. Do another question mark. You can see I can do a couple of things here, but I want to do the pool, and I gave it a very original name of my pool. So IP NAT inside is the flavor of NAT. We're going to bind that list with that pool. And as soon as I hit enter, we should be good.
All right, let's test it. Let's test and see. Can
so
PC1 now reach the internet?
PC. So that's the same address as the server I tried pinging earlier. Look at that. Got magic.
Absolutely.
Ping worked. What I want to do, I just want to quickly go back to the edge router because I want to pull up probably the most useful command when you're verifying your NAT. And that's the show IP NAT translations command. And this is really it was the inspiration for that first question in the Slido poll, right? This is the command that allows you to see the translations that are happening live or that have just been triggered by some traffic. In this case, it was ICMP traffic. And I don't know, Hank, the way I look at it, again, I kind of start from where that packet started from and then where it ended up going. So I can see that the packet came from this .6 machine, 10.6, which is PC1. And as soon as that packet hit the edge router, that it got translated to the .2 address from the pool. Remember, the pool was .2, .3, .4. So I grabbed that first address in the pool. And where was it going? Well, it was going to this global address, which ends up being the same as this other one here. And that's the address on that server. That makes sense?
It does. It does. And for what we're trying to do in the CCNA exam, as Patrick, you mentioned, right, we're focused on inside NAT, right? And so that's the idea here. So in an inside NAT type of a setup like this, the outside local and outside global should always match, right? Those addresses should always be the same.
Yeah.
And that's at this level of what we're trying to do with NAT. Just focus in on that. That's what you're looking for here. All right. So PC1 can get out. Can PC2 get out? I think there's a PC2 or the server.
A little server. Yep. Good point, because it's coming from a different subnet. So let's make sure that it's able to ping as well. 209.165.2.1.10. There we go. That works fine. And again, if I go back quickly to the edge router and pull up that show IP NAT translation command, I got this one as well. So I can see that this was the original ping, right, from the 10.6, that PC1 client. And this is that brand new ping that I just sent. So from the 30.30 address. And notice what happened. It got the second address from the pool. So the first one got the first address from the pool, .2. And the second got the second address from the pool, .3.
Yeah. And so now we've seen the translation, the network address translation. So we've got two hosts. Each one of them have an address, 10.6 and 30.30. And those addresses have been translated from local to global. So this kind of brings it together. Why is it called network address translation? It's been done. Now we sent off that ICMP packet from PC1 and the router made the translation. And so it looks like it's still kind of kept a hold of that, right? So future packets, future traffic from PC1, right? We've already kind of identified like that's the address it's going to use when it goes off to the internet.
And I guess the question you can ask yourself is how long will it keep a hold of that address, right? It's created a binding, right? A NAT binding between that 10.6 and the 200.2 address. So the private to public address. If you do that same command, the show IP NAT translation verbose, you can actually see how long it will keep that address for that client. It started at 24 hours and it's starting to count down. So it's going to keep that address for a long time. And I'm wondering if folks are starting to wonder about the problem that we might encounter quite quickly. If I start deploying more PCs, right, Hank? If I add more PCs in the 10.0 subnet or more servers, I'm gonna hit a problem pretty quickly, right?
We will, right? So the idea here is IPv4 address exhaustion. Too many hosts, not enough IP addresses. We'll just run into the same case here, right? We've identified 3 different addresses in our pool. If we had 4 hosts that wanted to get to the internet, only 3 of them could go within one 24-hour period with this kind of standard configuration, which is what we're going to see how to tackle in a minute. But before we do that, can we go in and check in with Rigo, see how folks have done with their second question?
For sure.
Yeah, let's bring Rigo back.
Yeah, hey guys. So in our latest poll, we had which type of NAT implementation is deployed on the edge router. And then we also had an exhibit on display for everyone to refer to. And it looks like we actually had a good mix of answers here, with the top selection being static NAT. But how do you guys think our audience did here?
Let me have a look. Go ahead, Hank. I was busy typing away here, so I'm just trying to
Oh
catch
no,
up.
you're good. So I think this is good, and this is one of the reasons I wanted to bring this back in. I really, really like this question that's in place because it requires kind of a higher level thought process from our candidates that go in. And so if we look at these, what do we see in the document? We see 4 different hosts, and each one of those hosts have been assigned a dedicated IP address. And
Yeah.
so this is one of those areas where it's not PAT. There's no port address translation going here. Everything is going to a single address that's in there. Now, so that takes out the overload options, right? Those ones are not going to be the ones that we're at. Or we don't want something with overload. And overload is also known as PAT that goes in.
Mhm.
Now the question comes down: are we static or are we dynamic? Now, Patrick, when you look at this, how do we identify whether this is static or dynamic based on this output?
Yeah, I mean, we were just seeing it a few seconds ago when I was sharing the CLI from the edge router. There was a funny, there were actually 2 entries, right? There was an entry where it's an ICMP something, but then just above it, there was another kind of more blank entry where it showed kind of a permanent binding between the internal address and the external address, like, or private to public address. So that's how I would notice if it was static or not. How about
Yeah.
yourself?
Yeah, I'd be looking for those if they were kind of hard coded in there. Now, this is an area where the output isn't maybe quite as clear. It's not quite as obvious it goes in, but the correct answer on this one is dynamic without overload, right? So these were dynamically assigned, kind of 2, 3, 4, 5 as they went in. We'd have to do a little bit of kind of troubleshooting and dialogue to see kind of how the specific differences go in. But I think what you would see if it was static is you may not see the ICMP indications there. We would just be seeing the just the IP address to IP address hosting, because at that point it's been a static relationship that's been done.
We'll get to static towards the end, and so maybe we can kind of come back to this and have a look at what the difference is between it and the NAT translation when it's dynamic.
Yeah, absolutely. Awesome. So great job on this. I think the key aspect to recognize here is because we're not seeing kind of port indications and those things come after this, this is definitely not a PAT or not an overload use case.
Exactly.
And then we'll look at options to kind of diagnose and tell whether it's static or dynamic. But all right, Rigo, thanks for that. Let's go on and we'll bring up our next question while we dive back into the next piece that we've got here.
And just before we continue and I start kind of applying the overload feature to the NAT pool, I just pulled up some debugging output. So again, right, we said that one of the most useful show commands was the show IP NAT translation. The most useful debug command to see if it's actually working live is the debug IP NAT, right? So very, very simple command. So all I did here is I turned on that command and I sent a ping from PC1 to the external www server. And I really like this output because it's so easy to understand. And especially I like the little symbol of the arrow showing the translation that's happening. So you can see that the ping initiated from the .6 device, the address got translated to the 200.2, right, which is that first address in the pool, and on its way to this destination. And then as the traffic came back, right, because don't forget a ping is 2 things: echo request, echo reply. So here comes the reply coming back from the server. It hit the edge router to that 200.2 address. And again, I love this little symbol here saying, whoop, it translated the address and it sent the packet back to this internal private IP. Really, really like this simple to read debugging output that we get, right, Hank?
No, it is fantastic. It's one of those debugs. Not all debugs are this easy to understand what's going on.
Exactly.
The NAT one is one that's there, and I would encourage folks, as you're doing your hands-on practice, experiment with this debug so that you can kind of see what's going on under the hood. I will also caution: make sure, as with most debugs, if you're doing this and you've got a production network, if you also have a day job as a network engineer and you've got access to your edge router that goes off to the internet, I wouldn't run this one kind of on your production router, because you'll see so much traffic going in for every single packet that flows through. Just the output of the debug can start to bog down your routers. But great command in the lab and when you got to troubleshoot something.
So while Hank was chatting, I just did a couple of things in preparation for the next step, because we came up with a problem, right? We've got 3 addresses, and it's fine for now because we only have 2 hosts. But that really, in reality, there could be hundreds of hosts there. And if I only have 3 addresses in my pool, a bunch of devices are not going to be able to access the internet. So to be able to move to what we call an overload function, but this time I want to overload the pool, I just did a bit of tidying up, if you like. I did a clear IPNAT translation star. So that just flushes all of the translations that could be in memory. And I just cleared out the statistics, because when I pull up a show command later, I just want that to be nice and kind of fresh. And honestly, it's a very simple way. Nothing really changes in the config except one command. We're not going to do anything to the pool. We're not going to do anything to the interfaces, right? The inside and outside. The only thing we're going to do is just add that overload keyword. So I'm just going to remove the initial command that we had put in earlier, the no IPNAT inside source list 1 pool my pool. And we're going to add the overload keyword at the end. And I'll just go to the beginning of the line here and remove the no. So that's it. That's all we're doing in this particular step. And this should work. So let's have a look.
I love the confidence. This should work.
It should work. So the ping again to that external server, that's working from the PC1. And I can generate maybe some as well from the server.
If we want to
now
avoid
I've generated traffic from 2 sources.
Yeah. If you want to avoid them timing out, Patrick, just leave the pings going, right? And then we'll make sure that the traffic stays in the tables.
That's right. So IPNAT translation. Okay, so let's have a look at this output. Really nice and clear here. We've got packets that came from the .6, so PC1, packets that came from the internal server. We can see that they both got the .4 address. So again, depending on the order that you do this, how long you've taken, it could have gone back to the .2. Remember, we've got 3 addresses in the pool. We did clear the statistics and clear the translation. So right, it could have grabbed the .2, it could have grabbed the .3. It just grabs the next address available, basically. And in this case, it was the .4. And you can see that it's reaching the external server at that 201.10 address. But I think the thing we want to mention here, Hank, is the ports probably, right?
Well, I think there's 2, right? The ports are there because that's what overload is doing, port address translation. But also notice that when we did this without overload, when it was just NAT, we saw the IP address and the host are kind of locked together. They had a time range that was going to be maintained. Yeah, and we don't see that here at all, right? Yeah, we don't have the IP address, the global to local addresses that are kind of left in the table for use later.
24 hours.
Yeah, for 24 hours. These ones are just there as long as those ports are being used for whatever the application is. And so that's another kind of key as you look at it. Because we didn't have those, we knew that it was this port address, the overload.
So yeah, I'll let that ping run like you suggested, because I do want to show you with the verbose output. This is really interesting here. If I do verbose, have a look at this. So I just sent a fresh ping. Remember earlier when we did the ping, it was like 24 hours. It's not 24 hours anymore. It looks like it's a minute, right? So for ICMP, a binding is quickly flushed out if it's not, in this case, it's getting refreshed constantly because I've left the ping running. But if I don't do that, within a minute, that entry is going to get removed from the binding table.
Yeah. Awesome. Now I like
we have a chat about the ports though. I think not a deep dive, but a couple of things. Students often ask me, why did it pick this port number? So what's interesting here is it usually starts at 1024 and then just grabs the next available port after that, port number that's available, right? So if those ones are taken by other applications, it'll jump to a whole other number, a whole other range of available ones. So that's a quick chat about that. But Hank,
yeah, one thing to keep in mind too. So ports are typically something that we talk about when we're talking about TCP or UDP, like a TCP port or a UDP port. And I think, Patrick, if we're going to do, we should have time that like the SSH example, we'll see those being mapped. ICMP isn't a TCP or UDP protocol, right? It's just ICMP, it goes over. And so what we're seeing there in kind of the port holds are kind of pseudo ports that are being assigned back to the ICMP application, just so that the router can keep track of where things are going in this, guys. I think there's an application ID, there's some sequence number, I can't remember the specifics, but it serves that same purpose from a port perspective for the the non-TCP or UDP application. So if we can see like an SSH example going through or something else, Patrick, we can
That's what I just did. So yeah, so
okay,
from PC1, I'll just scroll up to show you what I did here. I used the SSH command and hit the IP address of that external server. A bunch of things happened. It was like, oh my goodness, would you trust this fingerprint, right? Don't forget SSH is authenticated, it's encrypted, so we need to accept a certificate here and it's self-signed, all this kind of thing. So I said, yes, it's perfectly fine. I'll accept that. Then it asked me for a password. We know that all the usernames and passwords in our CML topologies is Cisco. And as soon as I did that, you can see I'm now SSH'd to that server from PC1. Now, if I go back to the edge router and I click and I pull up, let's say just the regular one, we have a nice entry here, a TCP entry this time. Notice it jumped to port 4096 in this case. We can see, though, that it is the SSH entry because of the destination port for 22 in this case. So just showing you different examples of different output. And I think if we do a verbose for this one, I think we're back up to 24 hours.
Yeah, so a couple of pieces on this one here. So here we can actually see the port translation kind of in its more native fashion because we're talking about a TCP based application here. And so the port that's shown on the outside, both local and global, is 22. That's the destination port because we're trying to reach SSH. And the inside local is using port 52230. And so where's that come from? Well, that's just the client, right? PC1 in this case went through and just picked a random high port to say, this is my source port. I'm just sending from here. And then when the router gets it, it needs to go through and identify that, translate the port to something it'll keep track of. And the routers typically, like we see here, right, start at 4096 and they'll just start incrementing as they go through. Some router operating systems may go random on the port selection. It's kind of just up to the inner workings of the router, how it picks what port to do. But that's the translation that's key, because we could have multiple servers or multiple hosts inside, all SSHing to that same server. And the router has to keep track of which packets go back to which hosts, and it's done based on that translation table. Which port that's coming back in goes to which inside host when it does the translation. So
I'm just doing a bit more tidying up again because we're ready to kind of migrate to that third option. So right now we've overloaded our very small pool of 3 addresses, but at the end of the day, unless I have tens of thousands of internal hosts, I might never end up using the second and third address in the pool. I might just keep overloading that first one. If I do run out of port numbers, it'll then start cycling to the other ones. But I would, right, Hank, we would need a lot of internal hosts to maybe get to that, or use access lists differently. But anyways, that's a whole other conversation. In this case, we're thinking, okay, hang on a second. I'm paying my ISP for these 3 addresses. Do I really need all 3? Maybe I don't. Maybe I can just do what I'm doing at home on my little broadband router, what Hank is doing at home on his broadband, what you guys are all doing at home with your broadband routers. You have one public address on your router, and it's doing NAT overload. It's doing port address translation and specifically overloading that address. So I'd like to migrate to that functionality. While I'm doing just a bit of tidying up, should we just check the Slido poll?
Absolutely.
That'll allow me to do my stuff in the background here.
You can get yourself prepped. So I'll work with Rigo here to check in on what we've got. So we've got a question here. This is another graphics one. All right. So what do we got, Rigo?
Yeah. So latest poll, the R1 router, we have it configured for Pat, and then we have an exhibit here. So the question was, what is the possible reason that the address in the network are not translated? And this one has a good mix of answers, but I do see that access list 1 is misconfigured, has the lead here with 60% of the vote. And Hank, I'll let you speak to the correct answer here.
Yeah, no, I will say that the vote in the lead, right? Access list 1 is misconfigured is the correct answer on this one. So great job as you went in. Nice. And now this is another, I mean, Patrick kind of outdid himself on our Slido questions this time with really good example ones to go through. So what would this be? What are we trying to do? This is a verification task, right? And the blueprint does say configure and verify these pieces. So you've got to be able to kind of understand what's missing. And so looking through the given configuration and kind of the problem, what do we see? Well, we see our hosts, PC1 and PC2, are 192.168.11 and 192.168.12. They're both on those /24 networks. And so as we look at our configuration that's in place, it's the ACL that's the issue, right? We've got 192.168 0.0 with a wildcard mask of 30 and then 255. And so that access list won't match either PC1 or PC2. So honing in on that as the problem. Great job, everybody, kind of diving in. Excellent work kind of identifying that problem.
And like Hank was saying, right, configure, verify, and for the previous question where we had that output from the show IP NAT translation, that kind of exam question would almost fall under the interpret verb, right, where you're shown an output. It could be a debug output, a show output, and you need to figure it out, right? So they like to use the word interpret as well. You might see that verb in the blueprint as well.
Yeah.
All right.
Awesome.
I think we can go back to sharing my screen.
Yep.
And while you guys were checking out my challenging Slido question, I just did a bit of tidying up. So I removed the overload of the pool, right? So I removed this command that we applied earlier. And while I was tidying up, I decided we'd get rid of the pool completely, right? Because we've called the ISP. We've said, listen, I don't need to pay you anymore for all these addresses. I'll just use that 1.6 address and I'm going to overload it. And the command is almost identical to the previous command where we overloaded the pool, except instead of overloading the pool, Hank, right, we're overloading the outside interface on the router, which has that .6 address.
Again, excellent. Awesome. Nope. That's fantastic. So let's do some pings and see if it's functional.
There we go. So the pings, notice that's the only thing I've changed, right, folks? So I didn't change the interfaces. They're still configured inside and outside. I haven't touched the access list. It's perfectly fine as it is. All I did is change the way that the NAT functionality has been configured. And if I pull up the show IP NAT translations command, here we go. So this is what it looks like when we've got some traffic that's been triggered by PC1. I guess I can also send some traffic from the server. That'll make things maybe a little bit more interesting in the output of the show IP NAT translation command. Let's pull this up. There we go. So now we've got two entries. Has it changed that much from the pool overload? It's really just here.
Yeah. I mean, it's just the address that's in place. I think fundamentally what you see with interface overload or pool overload is the same thing. There's an IP address that's used for the translation. It's just a matter of where does the address come from? Is it a dedicated set of addresses that you've carved out and said, I'm just going to use it for this? Or is it the address that's on the outside interface for address? Maybe you only have one address, as you mentioned, Patrick, that went through. So under the hood, like how it works doesn't matter. It doesn't differ that much between pool and interface on here. Awesome. And we can see very similar to what we saw earlier with the overloading of the pool. These are only bound for a minute. Obviously, they keep getting refreshed here because the pings keep going through. I could do the SSH that we saw earlier as well, just to show you an example of that. So I'll log into that, and if we pull up the show IP NAT translation command, maybe not the verbose to start off with, right? So here, what's interesting is you can see the .6 device. That's the ping, right? It's still there. It'll time out, right? In a minute, it'll time out and disappear. But then we can see the SSH entry, right? So we can see the destination port is 22. This is like the random port that it chose for this connection, 44722, and off it went using the .6 address again, overloading that. Awesome. All right. Hey, before we move into kind of the next piece that's here, I'm looking at the questions coming in from the chat. We've got a good one here from Timothy. Go for it. So we've got dynamic overload. Is dynamic with overload the best practice configuration, or is it use case dependent? So I was holding this question so we got to this point because we've talked through a few different things. We've seen dynamic pool. We've seen dynamic overload with a pool. We've seen dynamic overload with an interface. So is there a best practice? Like, how would you answer this question for somebody? Dude, this is the answer that I hate the most giving. Really, it depends. Right? We hear that so often in networking. It's an awful answer, to be honest, but it does really. You know, like I'm at home right now. Do I need a pool for my home router? Of course not. It would be expensive. Unless I'm doing some very funky things at home and I've got multiple devices that need maybe a static NAT, right? And each one needs a very specific address. We're going to get to static in a second. But it's really use case dependent. Is it a small office, a medium office? Do I have thousands and thousands of internal, phones and PCs and all kinds of devices? It really, really depends. I mean, Hank, you've seen some different deployments. Which one kind of stands out for you? Yeah, I agree with you on that. It's the depend side, and that's the part where, as you kind of become more of a mature network engineer, you see more examples, you start to see the use cases, and work with your senior engineers that are out there to figure out what fits in. I will say, for an organization that's large enough, like maybe a small office or a medium business that is offered more than just one interface address, if you're offered a /29, which is fairly standard, right? A /29, and you get a handful of addresses.
Yep.
My go-to is always to dedicate one address to the router, right, for the outside interface of the router. And then maybe if I don't need a ton of addresses, maybe just one separate address for the pool.
Yes.
And the reason is there could potentially come a point where something happens. Maybe you get a host on your inside of your network that gets compromised by a virus or some malware, and then it does something bad, and that address that's being used for internet access gets blocked by some public provider, a security piece that's there. What you don't want to do is block the IP address that's on your router, because that can cause troubleshooting. If you have to change the address, that can be a problematic for all sorts of different reasons. And so if someone's asking best practice, I'd start with, it depends. What are you trying to accomplish? What are your use cases? But if you have the ability, I would usually say give one address dedicated to your router, and then dedicate one or however many addresses are appropriate for a pool with dynamic overload. And this is kind of the key aspect here, is when your goal is just kind of outbound internet access for your inside hosts. It gets a little different if you're trying to provide access to a server inside, which I think is what we're going to get into next.
Exactly. I hope people picked up on what you just said, because it's a really interesting use case. So Hank mentioned creating a pool. So still creating a pool, but how big was that pool that you just said that you create? One
address.
So the starting and ending address are the same address. I know that seems weird, but that's a really nice way of okay, so I've bought a bunch of addresses. We're going to overload this one. If ever something happens to that one, I've got others that I can deploy and retire this particular one until I sort out the problem. So it's possible to do that. A pool of 1, a pool of 2, a pool of 10, right? It's completely up to you. And again, sorry for the answer, but it really does depend on the use case.
Yeah, absolutely. Awesome.
Yeah,
All right.
with a little bit of time we've got left, static NAT needs to be deployed. I'll just show you the topology, folks, again. And this was the binding that I want to create. In other words, I want to allow devices from the internet to reach the server, because it's got a web database. It's got a service that people on the outside need to be able to access. I need to configure on the edge router some static NAT. There's a bunch of different ways we can do static NAT. I don't know if you guys at home, maybe you can tell us in the chat what kind of online games you're playing. Maybe you're hosting a server internally and you had to open a port on your firewall to do this. We're not going to go all the way that far. I'm just going to do a really kind of simple, clear example of a static NAT, which will NAT basically all the ports. But if you're doing any kind of funky gaming at home and you've opened a port on your firewall and you're forwarding it specific, like my son for Minecraft when he was younger, I remember we had to forward specific address, specific port to his machine internally. That's another flavor of static NAT, but with a port binding. Here, I'm not going to do that. I'm just going to keep it as simple as possible. And it kind of looks like this: IPNAT, inside, source, static. And then the first thing we need is you can see it right there. I hit a question mark, the inside local address. So 192.168.30.30. Oops, maybe not 40.40. That doesn't exist. 30.30. And then if I do another question mark, inside global address. This time it's the address that I want to assign to it. So 209.165.200.5. So you remember, right? We had a bunch of addresses. We kept some for the pool, and we had the .5 I knew we were going to use for this. That's it. As simple as that. And again, it's basically just attaching those two addresses together. And let's check it out, see if it works.
Before you do traffic for that, Patrick, so we haven't sent any traffic through it. Do your show IPNAT translations command to show that the translation is kind of like hard-coded, like it's been set, it's statically configured. Right? Nothing's gone through it, but the router knows it's there. So any traffic that matches either of those addresses will trigger this piece. So I've got a couple of questions I'm hoping we can get to live here. So let's kind of quickly show this and then hit some of these questions before we close up with Rigo.
So which address am I pinging? The 192 address? No. 209.165.200.5. There we go. So the ping is in fact working. Oh, sorry. I'll let it go. And if I go back to my edge router and I pull up that show IP NAT translation, we've got some entries, right? So very strangely here, there's 2 lines for ICMP. It's because I sent one initially and then I stopped it and then I triggered another transmission of pings. And so I think that's why we're seeing 2 different lines here.
Yeah.
But yeah, there's the entry for our static NAT.
And if you were to send traffic from the server, right, if you were to try to SSH back to the World Wide Web server, it would still use that same static translation. We've got the interface overload, I think, still configured. It's not going to default to that because we've statically said this host uses this IP address. So that static translation takes effect over the top of the dynamic pieces that are there.
Yep.
So awesome. All right. So a couple of good questions. So I do, because these are really good. I want to make sure we've got time before we have to
I've done the demo. So yeah, let's take the
so let's bring Rigo back and hit some of these questions that are there. So there's one, where did they go? It says, how does NAT interact with passing traffic through a firewall? Is NAT done at the firewall or at the edge router? Patrick?
Yeah. So if you have a deployment with a firewall, usually the firewall is behind the router. So the router would just have that connection to the service provider, and you wouldn't be doing NAT on that router then. The NAT would be usually deployed on the firewall. The firewall, not that it's designed to do that, but it's one of its most, I guess, important functions. And what's nice is when you have 2 devices doing 2 very specific jobs, the router doing routing and the firewall doing firewalling, you're allowing the functionality and the resources to be shared, right? And so the firewall can then take care of filtering and analyzing packets and doing the NAT, while the router can just focus on doing its job, which is routing. That's what I've seen, Hank. I don't know if that you've seen as well.
No, absolutely. That's the most common type of behavior. Now, as you get to larger enterprises, you may see some very kind of complex and different types of configurations, but I think what you described is pretty common. And so the last one we got here, actually from an anonymous member of the chat, which is pretty cool. Do these ports have any overlap when it comes to ports used for other configurations, such as Radius that uses 1812 and 1813? Will these ports be used for PAT? So how do those well-known ports fit in with PAT translations?
Yeah, so the well-known port, in our case, you could see it when we SSH'd, right? It was using that as the destination port. That's where it was going as a destination. In terms of the source, I think we talked a little bit about it earlier. It'll grab addresses from specific ranges. And I think what we saw was interesting. When it came down to a ping, it would usually use from 1024 onwards. When it was for TCP, it jumped to 4096 and would then use that range.
It is, yeah, because remember, ICMP is not actually ports. Those are just kind of sequence numbers and things for the ICMP protocol. Yeah. But when we're talking about UDP or TCP, typically it tries to grab ports that are outside of the well-known range. Now, if you've got an application that uses a port that's higher than kind of 1024 and gets up out of that piece, there may be some conflicting, but it generally isn't a problem because the router is not providing service on those ports. So they're not going to kind of conflict as it goes in. Awesome. All right. I think that's what we've got at this point for the questions. Great job, chat. Sticking around in there. Some really kind of interesting ones that came through that gave us a chance to talk through. Rigo, any final thoughts? We got one more Slido question to hammer through.
Yeah, absolutely. So we do have our final poll results here. The question was, static NAT is often referred to as which of the following types of implementations? And I think we have a pretty clear winner here with 1-to-1 taking 85% of the vote. What do you guys think of this one?
Yeah, I was just trying to come up with clever combinations of the word one and many and try to confuse you as much as I could. So yeah, so maybe we can say yes. The answer is 1-to-1 because you saw me do it a few seconds ago, right? One private inside address was bound to one public outside address, if you like, globally routed address. But the other ones are actually some of these are quite good. So the one to many or the many to one or the many to many. So what I was trying to get at here was obviously referring to the dynamic, right? So many devices using many addresses or many devices using the one address. So that's what I was trying to get at.
On that, Patrick, if the question was dynamic NAT, which one of these would you pick for dynamic NAT? Because I think there's some arguments to be made for different types of interpretation on that one.
Yeah, I would have to be careful at how I worded it. So when I was in class teaching this, I would say, many inside devices to the one address, right? So I would maybe use the many to one in that case. And then obviously we've got the overload for the other one. So, but as you said, we also have the many to many, right? I've got many inside devices and I've got many addresses in my pool. So you can use a combination of these two. I know, right?
You can certainly go down a piece. I would say that we generally would make sure, and we do a really good job. Our team does a really good job making sure that we try to remove any kind of unclarity or things that could
Ambiguity,
cause
right?
ambiguity. That's the word I
Yeah.
was looking for. Way better than unclarity. And remove any ambiguity from questions that you might see on the legitimate exams, the real exams that are out there. So awesome. All right. Any final thoughts here, Patrick?
I'm enjoying this quite a bit. So I think we could maybe tease what's coming. Do you know what the next episode is going to be, Hank?
I do. So our first part of the services was really focused on the IP services to get internet access. So DHCP, DNS, and now NAT. Now we're going to go into some kind of router services. So we're going to talk about the importance of Telnet versus SSH and how do you actually enable the SSH service on the router, and maybe a few other. I'm still fleshing out the content for 2 weeks from now as it goes in, but we're going to kind of dive into a little bit of device security services that are there.
And I can tease the next one after that. We'll come back to another service, which is mentioned again in the blueprint. It'll be NTP. So we'll have a look at network time protocol. The configuration for it isn't very, very complicated. But we'll have a look at how it works. And I think the most important part of that also will be, coming back to what I said earlier, the interpret verb. We'll pull up some show output from when we have NTP deployed and help you kind of work through what that output is actually trying to explain.
Yeah, so lots more good services. Rigo's been kind enough to continue to bring Patrick and I back to kind of talk through all of this nerdy stuff with you all.
So thanks for joining, everyone. We'll see you in a couple of weeks as after March break for folks here in Ontario and Canada, and we'll have a look at SSH and Telnet. Over to you, Rigo.
Awesome. Well, Patrick, Hank, I just want to thank you again for another great session today. Appreciate you sharing your knowledge and expertise with our audience. I hope everyone found great value in the information and presentation, and that it is helpful for your exam studies. Before we wrap up, just real quick, I just wanted to take a moment to cover a couple of quick items for you. We do have some resources that we've mentioned in this early in this presentation. So we have the CCNA Prep learning map that contains a couple of a list of resources designated to complement your core training and aid your learning experience. We also have a practice quiz that offers a series of questions that will help test your knowledge on the topics that were covered here. And then also, as discussed earlier, we do have some activity files for both Packet Tracer and Cisco Modeling Labs that'll help you get some hands-on practice. And of course, we can't forget the blueprint for the CCNA exam, which is your main guide to help you prepare for the topics that you're expected to know to succeed. And again, if you can make your way to these resources, you can scan that QR code on your screen, but the link can also be found under your Slido resources. And I also wanted to take a moment to cover the upcoming live streams. And I know Hank and Patrick just covered this a moment ago. So again, just reminders. So we got the next session coming up in 2 weeks on Thursday, March 20th. That's going to be at 8 a.m. Pacific time, same as today. Hank is actually going to be covering securing a network access from Telnet to SSH. After that, we're going to be hosting 3 more sessions that are going to be covering NTP. We got syslog and we got SNMP to wrap up this season of CCNA Prep. We hope you can tune in to join us for the next session as well as our next couple of live streams. If you haven't already, we do recommend that you register for the prep program so that you can receive email reminders and also easily add these sessions to your calendar so that you don't miss out on them. Again, go ahead and scan that QR code on your screen, register for the prep program on the hub page, or use that link provided in our resources. And last but not least, we have launched a poll on Slido, and we would really appreciate it if you can just take a moment to complete it and let us know how you like today's presentation. We always look forward to receiving your valuable feedback and comments. Thank you again to our presenters, to all of our attendees for joining us here live today. I hope that you'll have a great rest of the day, rest of the week, and we hope to see you next time on the Cisco Learning Network. Thanks so much, everybody.